Here now we want to summarize diffusive transport through single layer and extend it to other geometries. What we did was a concentration profile of a slab and mass flux. So we derived this one, and the mass flux would be given by this. Now the procedure that we did for slab, starting from governing equation and boundary conditions and solving them to get this concentration profile, can be followed in other geometries. And so if we do that for a cylindrical geometry, then we get concentration as a function of radius. We are not going to repeat this process of deriving this formula because we did an identical one in heat transfer, and those interested can look up chapter 4 or the steady state heat transfer chapter for the derivation of this equation. It is literally a substitution of C concentration for temperature. So here we have this concentration as a function of radius, and notice it is different from the slab. It is not linear. It has a log in there. Why is that? Why can't it afford to be linear? It's because in a cylindrical geometry, the surface area changes with radius. Surface area increases with radius. Now, mass flow has to be constant for all situations. Why? Because between two layers, the same amount of mass has to diffuse through, otherwise things will not be at steady state. So the same thing here for cylinder, the same amount has to go through two layers. So the flow has to be constant, but as you increase radius, the surface area changes. Now flow is equal to flux times area. So if the area changes here, then the flux would have to adjust. If this changes, then this has to change to keep the mass flow to be constant. And so since mass flow has to be constant, area increases, so the flux has to decrease as you go from inside to the outside. And that's what is the reason that the concentration is no longer linear. So the flux changes with radius, because if you take the derivative dc dr, then it will be a function of r. The same for a spherical shell. The surface area increases as we go from inside to outside. So even though the same amount of mass has to diffuse through each layer, the mass flux, that is amount per unit area, has to keep changing. So that's why the equation that we get for a spherical geometry is also not linear. So you have r here and r here, and so even though the mass flow, that's the amount, the rate at which stuff is diffusing through two layers, even though that is a constant, flux, that is per unit area, per unit of this area that keeps increasing, the flux has to then decrease. So in other words, the flux has to change with radius. Finally, the resistance for the slab was derived as L over dABA, and totally analogous to heat transfer, the resistance for cylinder and for sphere are written here, where all we did is substitute for K, the thermal conductivity, the mass diffusivity here. So that summarizes the single layer problems in slab, cylinder, and spherical geometry.